Already, this is now question. Jocelyn has a goal to double the amount in her short-term savings account each week. She opens her account with $25. The list at the right represents the projected dollar amount based on the number of weeks she has been saving. So, if she has $25 in the first week, then 50, then 100, then 200. Okay, this is term 1, 2, 3, and 4. Is this list geometric or arithmetic? Well, 25 plus 25 gets me 50, but then 50 plus 25 does not equal 100. So it cannot be arithmetic. Let's see if it's geometric. What is 50 divided by 25? That would mean I multiplied by 2. Then what is 100 divided by 50? That also means I multiplied 2. So is it geometric? Geometric, because we multiplied by 2. Okay. What is the common difference or ratio? The ratio is 2. Find the projected amount in her account after 6 weeks. Well, we could just do the fifth term would be 200 times 2 is 400. And then 400 times 2 is 800. So her A6, the sixth term, would be $800. $800 after 6 weeks. Jocelyn wants to know the projected amount in her savings account after 15 weeks. Would it be practical to just keep multiplying the common ratio? Why or not? I mean, you could totally do it if you stayed organized and wrote down the 7th, 8th, 9th, but it could quickly get confusing and you might end up saying the 14th week or the 16th week if you miscount. So it's not really that practical. So today we are going to learn how to write and use explicit formulas of geometric sequences. So let's review what a geometric sequence is. If a sequence of values follows a pattern of multiplying by a fixed amount, not 0, times each term to arrive at the following term, it is referred to as a geometric sequence. The number that you multiply each time is always constant. It's always the same. The fixed amount that's being multiplied is called the common ratio. And this refers to the fact that the ratio or the fraction of the second term to the first term yields this common multiple. To find the common ratio, you divide the second term by the first term. Then you might also want to do the third term by the second term, just to make sure the ratio is the same. Geometric sequences are not linear because they do not form a perfectly straight line. If we look at this scattered plot over here, where term 1 is 2, and term 2 is, 4, and term 3 is 8, and so on and so forth, we will see it doesn't follow a straight line, but rather it follows this curve-looking shape. And this is considered like exponential. The x is increasing by 1 time each time to go to our next term, but then the y is a multiple of 2, which means it's quickly going to multiply and become bigger and bigger exponentially, which is why geometric sequences are like exponential functions. So what is the explicit formula that we could use for a geometric sequence? An explicit formula of a sequence allows you to find any term in the sequence without knowing the previous term. All you will need to know is n. N is the term number that you are trying to find. Then A1 is your first term. Then R is your ratio. That's the number that you are multiplying by. Well, that's the number that how many times you are multiplying the ratio, because then you have your exponent, n minus 1. All right, so let's just go over how this formula is broken down. To understand how the explicit formula is derived, write the first 4 terms in Jocelyn's sequence as a product of the initial term and the common ratio raised to a power. So to get 25, our ratio before was she's doubling, so 2. But she didn't actually do 25 times 2 to get 25. She just multiplied it by 1, which means we would have a exponent of 0. Because 25 times 2 raised to the 0 power. She didn't double it yet on the first time. She didn't do anything. But then the second week, she doubled it 1 time. Then the third week, she doubled it 2 times. She doubled to get from here to here and here to here. That's 2 times. Then on the 4th week, she doubled it 3 times. So describe how the power of the common ratio relates to the term number. Well, here the power, the exponent is 0, and our term number is 1. Here our power is 1, and our term number is 2. So it's always that the exponent is 1 less than the term number. Kind of like how in the arithmetic sequence you're always multiplying the common difference by 1 less than the term number, we're doing the same thing here. Write an explicit formula to represent Jocelyn's sequence. Well, I know I have to write AN equals A1, which is my first term. My first term is 25. Then in parentheses, I put my ratio, which I was multiplying by 2. And then I put N minus 1. Explain how we would use this formula to find the projected value after 15 weeks. We would just plug in 15 for N. So 25 is our first number. Then our common ratio is 2. And we raise it to 15 minus 1, which gets us 409,600. And that was money, since we're talking about the money in her savings account. All right, let's look at this next question. Write an explicit formula to represent each geometric sequence, then find its indicated term. All right, to find the ratio, we do the second number divided by the first. And then we could also do the third number divided by the second, because we want to make sure that these are equal. Negative 18 divided by 2, that gets us negative 9. 162 divided by negative 8, that gets us negative 18, I meant to say. 162 divided by negative 18. We get negative 9. Our common ratio is 9. All right, our formula is AN equals our first term, which is 2. Then parentheses the common ratio, which is negative 9. And then we put N minus 1. So let's find A18. A18 is 2 times our common ratio, negative 9, raised to the 18 minus 1 power. We will get 2, parentheses, negative 9, raised to the 18 minus 1 power, which gets us, this is a huge number, but I'm just going to abbreviate it, negative 3.3 times 10 to the 16th power. That's how you write something that's written in that scientific form. All right, and let's look at the next one. Our common ratio, take the second number and divide it by the first. Take the third number and divide it by the second. All right. Negative 8 divided by negative 16. And let's see, negative 4 divided by negative 8. We get 0.5, or you could also write 1/2. It doesn't matter. So our formula would be AN equals, our first term is negative 16. Then the common ratio, I'll just leave it as 1/2 since a ratio is kind of like a fraction. Or you could put 0.5, and then N minus 1. So we want to find the 25th term. So all we got to do is plug in 25 for our N value. So we will get negative 16, parentheses, 1/2. And we will raise it to the 25 minus 1. Which gets us negative 1 over 1048576. All right, and let's look at this next question. All right, common ratio, we're going to do the second number divided by the first, and then the third number divided by the second one. Let's see, 81 divided by 243. And let's see, what's 27 divided by 81? That gives us 1/3. I know it gives us that decimal, but that decimal is 1/3. So our formula is AN equals our first term, which is 243, multiplied by our common ratio, and then we put N minus 1. And if I'm trying to find the 21st term, all I got to do is plug in 21 for my N value. All right, let's see, 243 And then we have 1 over 3. And we're going to raise that to the 21 minus first power, which gives us this big old fraction, 1 over 143,48907. All right. Usually on the Regents, we won't get these big old fraction numbers like this, but it's just so you get the practice in. Alrighty. Let's look at this next one. I want you to pause the video and actually try this on your own. Try to find the common ratio, the formula, and the 14th term. So to find the ratio, do the second number divided by the first, and do the third number divided by the second. 6 divided by -1, and -36 divided by 6, we get -6. So our formula is AN equals our first term multiplied by our common ratio, and then we put n minus 1. All right. So A14 is equal to -1, parentheses, -6. Our n is 14 minus 1. So we put -1, parentheses, -6, raised to the 14 minus 1 power. We get that our 14th term is 1.3 times 10 to the 10th power. Good. Alrighty, let's look at this next practice. Individual practice. I want you to actually pause the video and try this practice. Mr. Chester wrote several terms on the board. He wrote that the third term is 44. The third one is 44. The fourth one is 88, and the fifth one is 176. Is this arithmetic or geometric? Well, let's see. The fourth term, which is 88, divided by the second one is 44, and 176 divided by 88, that does get us 2. We're multiplying by 2. It wouldn't be arithmetic because 44 to 88 is adding 44, but then 88 to 176, you had to add 88, which is not the same amount. So it would be geometric because multiplied by 2, which means that we have a ratio of 2. And what's the explicit formula? We write AN equals our first term. Oh, we're going to have to go backwards to find our first term, so we're actually going to have to divide. 44 divided by 2 is 22, and 22 divided by 2 is 11. So A1 equals our first term, which is 11, multiplied by our common ratio, which is 2, raised to the n minus 1 power. All right, now let's look at this next question. 2 students wrote the formulas for sequence as shown below. Use the formula to mark each statement as true or false. If false, rewrite the statement correctly. All right, the first term of both sequences is 10. Well, here A1 is 10, and here A1 is 10. That's true. All right, true or false? Both sequences have a common ratio of 3. This one does have a common ratio of 3, but this one does not have a common ratio of 3. It has a common difference of 3, since this is our arithmetic sequence. So false, we could say Tyler has a ratio of 3, but Brielle has a difference of 3. Perfect. And now true or false? The third term of Tyler's sequence is less than the third term of Brielle's sequence. So let's find the third one of Tyler. So let's do Tyler. A3 would equal 10, 3 to the 3 minus 1 power. And for Brielle, we would have to do A3 equals 10 plus 3 minus 1 times 3. All right, let's type both of these into the calculator. 10 parentheses 3 raised to the 3 minus 1. We get 90, and then 10 plus 3 minus 1 times 3. We get 16. All right, so Tyler's equals 90, and Brielle's equals 16. They're saying that, right now they're saying that Tyler's sequence is less than Brielle. That's false. False. It's that Brielle is greater than Tyler because, no, it's that Tyler is greater than Brielle because 90 is greater than 16. All right. So you would actually say that the third term of Tyler's sequence is more than the third term of Brielle's sequence. All right, let's look at this Regents question. Which situation could be modeled using a geometric sequence? That means we have to talk about something being multiplied. A cell phone company charges $30 per month for 2 gigabytes. That's how much you start. And then $12.50 for each additional gigabyte. That means you're going to add $12.50. If you're adding, that's arithmetic, so it's not going to be 1. All right, the next question. The temperature in your car is 79 degrees. You lower the temperature of your air by 2 degrees every 3 minutes. That means you're subtracting 2 or adding -2. So that's arithmetic. The next one. David's parents have set a limit of 50 minutes per week that he may play online games. However, they will increase it by 5%. Oh, if you're increasing by 5, that means you're multiplying by, we change percents to decimals, so we would be multiplying by 0.05. I like that answer. And the reason why 4 is not the answer, because if she's saving an additional $15 each week, that means she's adding 15 to her original amount of 100. All right. Let's look at this one. Given the sequence x, x2, y, x3, y2, x4, y3, which expression could be used to determine the common ratio? All right, I know for the ratio I have to divide. So it's not going to be 1 and it's not going to be 2. All right, number 3. I see they took this first term and divided it by the second. Oh, no, we have to divide it in the opposite order. So it's not going to be that. And for choice 4, they did the third term divided by the second. They did A3 divided by A2. That's good. So answer choice 4, it is. Now let's look at this next one. What is the common ratio of a first term who is 5 and a third term who is 245? Well, let's see. Let's try all the answer choices. Choice 1 says 7. 5 times 7 would get me 35, and 35 times 7 would get me 245. So that's my answer. Let's think about why this is true. If you do 245 divided by 5, you get 49, which might make people think the answer is 49, but we have to separate that into the 2 different terms, which is 7 and 7. All right, and let's look at this one. What is the common ratio of the sequence whose first term is 24 and fourth term is -3? Well, let's try our answer choices. 24 times 2, we'll get 48 for the second one. That's not going to make sense because I need my numbers to go down, so it's not going to be 1. Let's try the second one. 24 times -2, that would be my second number. This would be my third, and that would be my fourth. Not going to work. All right, let's try the next one. 24 times -1/2. This would be my second number. Times this would be my third number. Times this would be my fourth number. Yes, that makes sense. Perfect. And I should have figured that the number had to be a number smaller than 1 since I seen that my numbers were going down in the sequence. And because I went from a positive to a negative at the end, that's why my ratio has to be negative. That wraps up our lesson on geometric sequences. Most important thing to remember is the explicit formula. We have a(n), any term we want, equals the first term times the ratio, and then we raise that to n minus 1. Alrighty, this wraps up all our lessons in Unit 6.